So electrostatic generators actually have always been a fascination of mine. Now electrostatics is one of those curious subjects that kind of reached its peak of development in the early 19th century and for no particular reason was dropped until about the sort of 1950s, 1960s. And we started getting more research into it with a few leading lights. A couple come to mind, of course, Jeff Romenko and A.D. Moore, who looked at these things. Now, the Wimshurst machine that we made was, as I say, beautiful, awesome, 19th century machine, but a relatively complex build, actually. And I was looking at A.D. Moore's thing because I'm looking for an electrostatic motor. Now, you can get loads of electrostatic motors, and some of them are beautiful builds, and some of them are teacups with aluminium on them, but still pretty interesting things. And I was looking for something, which is when I came across a motor-stroke generator by A.D. Moore called the die rod. So the die rod can be run in one way to be a generator, and then you can reverse it to run it as a motor, and I thought that's kind of ideal. The die rod's also actually a much simpler build than the Wimshurst machine, so I thought I would go through it. Now, the die rod really comes in two forms. It comes in a cylindrical form, which is like a drum, and it also comes in a circular form, like a disc. And we've chosen the circular form die rod because essentially it consists of 3 bits of plastic, 2 squares of acrylic, and 1 disc. And the disc goes in the squares of acrylic. There's an aluminium foil structure on it, and you spin that disc and it will generate, or you apply high voltage to the structure on the outside and it should spin the disc. So we have a much simpler task. The thing about the die rod really is it's all about the paper plan you draw, because once you've drawn the paper plan you can lay the disc on to draw the sectors, you can lay the side pieces on to draw the structure that's needed, and it's a relatively trivial thing. Now, I was going to do it from painting it, but I figured that was mildly unfair, since there aren't that many people who have the paint, but this is something lots of people have, or is easy to get hold of. It's that aluminium tape that you get for insulation and ventilation. It's sold in builders' yards the world over, and it's extraordinarily cheap. So I decided to make it from this stuff, just to make the whole idea that much more approachable. The first thing you do is you make a disc. And on that disc I divided it up like the Wimshurst machine into sectors and cut these petals out of the aluminium and covered both sides of the disc with those petals. Now normally you only cover one side, but on this one we covered both sides. But the die rod disc needs those both sides to be connected. Now there's lots of options obviously. We could just wrap it around there in a strip and that would do just Jim dandy. I've done petals, and then what I've done is I've drilled through the disc and I've made a soft solder rivet out of soft solder. This is basically tin actually, so they're tin rivets, and I've put the rivet through the disc. Let me give you a close-up of that riveting procedure. So right on the outer edge of the petals I've drilled 2mm holes on each petal, there it is, so that hole goes through to the petal on the other side. Then on this aluminium block I've drilled a 2mm hole there. I did try using these larger holes, but it actually bends the wire. And here's my tin wire, which is just solder, and it's 2mm wide. So I feed the wire through my 2mm hole into the little hole that I drilled there at 2mm, and I drilled it down to a depth of about 2mm. And then we snip that off at, surprise surprise, about 2mm. So that's our rivet more or less ready. Then we take a hammer and hammer the rivet down. Be careful to mushroom it over and not to bend it over, so you get a nice flat rivet like that. When you turn it over, you'll see the 2mm bit poking up outside, and just flatten that against the aluminium as an anvil. And you end up with the flat rivet that joins those two pieces of aluminium together. So that's the die rod radial disc finished. All the segments are on and they've been riveted together through the disc. Now here's the plan I'm working to. Okay, this plan I drew up, and I'll do it in a separate video on how to draw that plan, but you may be able to work it out yourself, or you might just not be interested, and it would certainly make the video quite long, so I'll do a separate video on drawing the plan. But the plan allows you to lay everything out and cut templates from it. So those sectors were cut out from the plan as that template. It was put onto a bit of card, draw around the aluminium, cut them out, stick them on. You stick them on by laying your bit of acrylic on the plan and following where the segments need to be. And that's because everything you make is a layer that has to register. So the next one we're going to make are the actual inductors and collectors, and our square of acrylic now fits that yellow square, and I can either draw around it if I was going to paint it with the ink, or cut out one of these things as a template for cutting the aluminium sectors out and just lay it over the plan, and it will guarantee, as long as you register the centres, everything else will be registered. So the next section is to make the inductors and collectors. So I'll make that and show you the 3 plates together, and I'll just do that by laying it on top of the plan. Okay, so there's my basic die rod with everything lined up, and because of the plan, of course, it all registers. And the first plate has that shape on it, and these are the inductors and collectors. Actually, these are the collectors here and here, and then these are the inductors here, and these join the inductors and the collectors. So that's the inductors and collectors on the first plate. Then obviously we have the rotating disc where we've got sectors on both sides, and those sectors have been joined with soft rivets. And then we've got the rear plate where we've got the other side of the collector, because the collector surrounds the actual disc here. That's the neutralising bar there, and that's on the final plate. So all we have to do now is drill some holes in this and bolt the whole thing together, which is exactly what I'm going to do. So that's it bolted together. I mean, it's just these 2 plates are held apart by the 4 bolts that you can see on the corners. Obviously I've inserted an axle, and that's free to rotate. Now if you look at the back there, you'll see that these ones, which remember this was the collector and the inductor, have been joined with a bolt all the way through to the collector on that side, and that is the high voltage point. Now this one obviously, oh, wrong way around. Yep, there we go. That one is the neutralizer bar. Remember, these ones are the collectors. So the only thing they're missing are brushes, and I've drilled the holes out, and you can see them there, right there. And we're going to make some brushes and insert the brushes in those holes, and then this is ready to go, pretty much. The brushes we're going to make in exactly the same way that we made them for the Wimshurst machine, and that is carbon fibre towel, bent over, tied up, and then stuck through those little holes that you just saw. So not a lot to this if you think about it. So I set this up, as you can see, and all I've done actually is connect the meter to the high voltage outputs that I pointed out earlier, and stuck on a handle onto the back so I can turn it. So I was going to run it as a high voltage thing, and then I noticed this. Now I've put the meter on and it's on the volts reading, and as I turn that handle, I mean, that's generating about 1.52 volts with what I just did there, which I thought was really kind of cool. Now obviously it's high voltage, so you'd expect it to be, it's an induction machine, you'd kind of expect that. But then when I put it back onto the amp reading, I mean, this is points of a micro amp, okay? So it's 164 microamps, which is granted a tiny bit of power that's coming out of there. However, you have to think about it, don't you? Because there's no coils of wire here, there's no magnets here. It is just set up with the brushes across those plates collecting it by induction, and that is absolutely awesome. According to me, it's awesome, because we did this in aluminium because I thought it would be nice, and I thought people could make one out of aluminium if they wanted to. But we know that this actually works with that conductive ink. Now, I've done it in this radial form because my thought was to stack a whole load of them up, basically, to make a more powerful device. And that would hold true for this as well. With gentle rotation, we can get a usable voltage out of it, a small amount of power, but then there's nothing in here apart from a bit of plastic and some aluminium foil, and if we paint or print it, there'd be nothing apart from a bit of plastic and some paint. Now that got me kind of really interested, because what you're looking at there obviously is printing a generator. There's a distinct possibility that we could print a generator for pennies that would generate usable amounts. I mean, you know, when we're talking about points of a micro amp, then we'd need about 1,000 plates to actually produce something. But even so, I thought that was absolutely riveting. Now, it's obvious that the speed of rotation So the faster I turn it, then the more power that it gives out. So we could also include the speed of rotation, stick a motor on there and see what happens, as well as the number of plates. And that'd be fascinating as an experiment to put a motor on and see what it generates in relation to RPM. Now there is another thing that's really interesting about this actually. It is set up as these plates here. Now if I seal those edges, of course it's going to be sealed from the atmosphere, and electrostatic machines suffer greatly from atmospheric changes, particularly wet atmospheres. I mean, we're having a really rainy day, so I didn't expect very much from it, to be honest. But we could seal that and put some desiccant in the bottom and make it immune from those things. So as a prototype and an idea, I actually thought that was much more interesting than it would be just as a generator, as an electrostatic device. So it has possibilities of being a printed generator that we can seal from the atmosphere and would cost absolutely peanuts, because like I said, no coils, no magnets. Isn't that fascinating? Anyway, I thought I would share that with you because I found that particularly fascinating. I mean, the idea about this is it is a die rod, so it was going to be both a generator and a motor. But that particular aspect of it that I just happened to notice, I think is well worth further investigation. So I thought I'd share it with you because it looks like it might be going towards a printed generator. That's going to be cool. Anyway, I hope you enjoyed the video. I hope it sparked some ideas, and thank you very much for watching.